The first example we're going to do using L'Hopital's rule is a limit that we've already seen the answer to geometrically in Chapter 1, but now we're going to look at it through the lens of indeterminate forms and L'Hopital's rule. And so the limit I'm talking about is the limit as x goes to 0 of sine x over x. If you still remember your Chapter 1 theorems, you already know what the answer is going to be, but let's use L'Hopital's rule to figure it out. First, as we do with any limit, we try direct substitution. So I try plugging in 0 for x. I get sine of 0 over 0. And sine of 0 is 0. So I get 0 over 0. This is an indeterminate form, which means I need to try something else. Since it's a 0 over 0 indeterminate form, I know L'Hopital's rule applies. So I'm going to indicate that I'm using L'Hopital's rule, which I'm allowed to do because I already confirmed it's a 0 over 0 indeterminate form. And L'Hopital's rule states that if it's a 0 over 0 indeterminate form, then the limit as x goes to 0 of sine x over x is going to be the same as the limit as x goes to 0 of the derivative of sine x over the derivative of x. So this limit will be the same as the limit as x goes to 0 of the derivative of sine x, that's cosine x, over the derivative of x, which is 1. And now we try direct substitution again. I get the cosine of 0 over 1, well, that's just the cosine of 0, which is 1. And that is the answer we remember from Chapter 1. The limit as x goes to 0 of sine x over x is 1. We've seen it geometrically before, and now we're seeing it using L'Hopital's rule.